All right. Well, welcome back, everyone. I hope everyone enjoyed our session there and a little bit of a break. I wanted to get a little housekeeping out of the way before we move any further. And, based on the feedback that we received yesterday, surrounding the development portion of the sessions, we're going to actually extend that QA. I know we had some extra questions yesterday we didn't get to. So after Pami is done talking today, we're going to go ahead and extend that QA session. So we're going to bring Steve Lake and Kevin Clark back in here to answer any additional questions you may have. So I just wanted to let everyone know about that. But that kind of brings us into our next presentation. And unfortunately, I have to apologize for any technical issues we might have had on that last call. We're doing our best with what we have. Unfortunately, we aren't CNN, so we're doing the absolute best with what we have. So, but that kind of kicks off our next presentation, and so I'm extremely excited about this one. We're very grateful to welcome one of our valued customers. So happy they can take the time with us this morning to kind of share their experiences with the dataPARC software. So if you wouldn't mind helping me in welcoming Tyler Fidun, the applications manager at Energy Transfer, and he's going to tell us about how the company's okay. So I take that back. Tyler is okay. So Tyler is coming up. I skipped ahead. Excuse me here. So actually, we are going to be sharing some important updates around the Data Park historian at this session. So unfortunately, we're going to be hearing from them a little bit later on, but our presenters for this session are going to be Steve Lake, our software development manager, and Aaron Mosier, project engineering manager here at Capstone. So welcome, gentlemen, and we're looking forward to hearing what you have to say about the historian.
Good morning. Thanks for joining us for the dataPARC historian presentation. I'm Steve Lake, the technology director at Capstone, and I'm joined by Aaron Mosier, our engineering manager.
Thanks for joining us today.
We've got a lot of content to plow through this morning, so we'll try to keep on schedule. So we'll quickly cover the agenda. I'm going to run through the motivation and goals as far as why we're pursuing all these historian updates and what the end goal is, as well as the current state of the application, and then Aaron's going to take over to talk a little bit about what's happening after the initial release of it. So the current historian that many of you are familiar with, the original architecture as far as how we store files on disk goes back about 20 years ago, and since then things have changed quite a bit, especially around, say, data density, where I know back in the day we typically only stored maybe once a minute data for any given tag, and now we're quite often doing sub-second data. So the data density has increased dramatically. And also, when I first started back in 2005 at Capstone, we typically had single site installations where it was one site looking at that site's data. And these days it's a lot more common to have multiple sites looking at each other's data, as well as corporate that might be separate from all the sites also wanting access to everything going on in their facilities. Security is also another big concern, especially when we start looking at sending data across the internet. We want to make sure it's both encrypted and properly authorized for who can access what. And big data is another thing that's common these days, where we're being asked how to not only store large amounts of data, but then also export almost everything that we might be storing into big data applications for deeper analysis. Quick example, I was just thinking about some of the technology that's changing these days. Cloud hosting, especially, we're being asked more and more frequently how we can host our applications in the cloud, where then the facilities are pulling everything over the WAN. I already mentioned storage capacity. I had a picture here of an old disk drive I found in a pile of old hardware I was looking at the other day. It's a 2002 120 gigabyte spindle drive. And I saw Samsung now has a 30 terabyte SSD, and all the performance characteristics are through the roof compared to what we were dealing with a few years ago. And we realized a lot of customers are still going to be using spindle drives, at least for the next few years, as their primary storage. But our aim is to handle performance well on both spindle and SSDs going into the future. I also have a couple of notes about a large number of CPU core counts and huge amounts of memory that we're seeing new servers be deployed with these days. So how we can make sure we're properly utilizing all the resources we now have access to. So here's a quick list of some of the shortcomings that we know our current historian has. We don't like to admit that they exist, but they do, and we'll acknowledge them and try to fix them going ahead here in the next historian. So the first one is the lack of data types. We really only store single precision floating points and text values in the current historian, and a lot of people want to store either double precision or integer values and all the other common data types, Booleans. We're also using SQL Server to store text data. So usually that's not a big issue if you don't have a lot of text data, but we have some cases now where there's maybe hundreds of millions or billions of text values being stored in the SQL Server database, which makes backups a bit of a challenge. There's also a one-to-one mapping for interfaces to Parquet sources. So every PARC.io or port.io you have configured is mapped to a single Parquet source, which could be dozens or potentially hundreds of sources. The current historian is also tightly coupled to the client applications and database. So you need to have the CDC config database be accessible by your historian because that's storing the tag configuration. And you also need the full Parquet client installed to even run the historian. Not too many people have run into the next limitations where we can only store 4 gigabytes per day per source, or the max of 50,000 tags per source. It's a limitation that's there that we're removing in the new historian, as well as we don't have a documented SDK for reading or writing or configuring. We do have some sample code out there that shows you how to do that, but nothing documented that we guarantee will work from version to version. Collectors, transferring data into historians, it's all based on files. So we have to, the collector writes a file that has to then be transferred over to the historian, either directly through, say, Parc.io or port.io, or via one of our applications like port.io file copy or Parc.io file copy. And while that works well, it adds extra latency from the time a value is read by the collector to when it's available in the client. And I mentioned in our previous presentation, the 7.0 feature for session 0 is challenging to get into session 0 to manage or monitor a lot of our applications that have UIs on them. So trying to fix that and have web-based UIs for both management and monitoring of the historian processes. Last point I'll mention is data's typically been stored in local time in our existing historian, which makes challenges when daylight savings shifts back in time when we have a duplicate hour. So that's something we also want to resolve. So some of the initial goals for our new historian is to store all data in the binary historian file. So that would be the daily files that you guys are familiar with. So pull all the text data out of the SQL Server, put it in those files, as well as extend all the new data types that will be stored in the same files. Improving overall performance, that would be for both reading and writing data. We want to scale better across hardware and offer better overall performance and remove the constraints I previously mentioned, like the 50,000 tags per source or the 4 gigabytes per day per source. So simplified deployment and management, that would be reducing the number of applications we have to deploy, and also having the web-based management for monitoring, configuring. One of the things we just recently started to look at is supporting new deployment scenarios like containers, so you could deploy into an Azure container and run the historian there without having to have a full virtual machine, as well as adding support for running the historian in Linux and supporting different databases for the configuration besides SQL Server. Another big one is the public SDK. We'll have a well-documented SDK that shows how to read and write and configure the historian. So we'll be working closely with our customers that are interested in this SDK to make sure the functionality that you want is in there. And then there's an overall goal to build a platform for future functionalities. We have a lot of ideas on things that we want to do in the future, and we want to make sure that the new base historian is able to support that. So current state, we've been working on this for almost a year now. We've rebuilt the entire historian in .NET Core, which is Microsoft's newest framework that's cross-platform, so it can run on Windows or Linux. We've pulled out the historian configuration into its own database, so you'll no longer need to have access to the CDC config database to run the historian. It will be completely independent and then can be mapped into a ParkView database, just like any other third-party historian. It's using gRPC-based communication, so this is the new communication, the channel that was originally developed by Google that we use for all of the communication between the clients and the server. So your data collectors will send all of the data over a gRPC channel to the historian, and clients will read data back through the same channel. So it means we only need one port open on the server for all of the client and server connections. Web-based configuration and monitoring will have a web-based portal that exposes all of the historian configuration and collector configurations. So you can define your historian interfaces and tags, as well as monitoring everything that's going on in the system. And I'll have some screenshots later on how that's looking. Big thing here, number 5, the migration utility. Since the new historian is completely independent of the existing one, the data files that it uses are not compatible and the configuration is in the new database. So to help ease the transition for existing customers that want to migrate to the new historian, we have utilities to import all of your tag and source definitions and PARC.io collector definitions, as well as the data into the new historian. We're supporting all .NET value types, so that would be all the different floating point types, integers, booleans, text data, as well as arrays. So you have scanner data in arrays, we can store those, as well as a new digital text type where you can map a numeric value to a text value and trend both. I'll give a demo of that in a bit. One of the big things we're now doing is tracking statistics as far as how much data a given tag is typically using in a day, so we can be smarter about how we're allocating new files when we create them. Right now we have an existing historian, we have a utility called Park History Defrag that can go and defragment a file, and people that use that know that can make a 10 to 20 times performance difference when reading data out of those files off a spindle disk. So we're trying to be smarter in the new historian to have to avoid doing that. And along the line of simplifying deployment, we're rolling a bunch of our applications that are currently independent apps like Park Aggregate and Park History Defrag and the import server. Those will all be built into either the historian or Park.io. And by default, we're storing all data in UTC. So we can view data in whichever time zone you want, but we're storing it in UTC. So we no longer have the daylight savings shift issues for time zones that have daylight savings. So I've got a few screenshots here of the current state of the new historian. I'll just run through these real quick. So the new historian, we have a notion of interface groups, which is similar to a ParkView location where you can have sources in a location in the new historian, and we have interfaces in interface groups. And you can set those up however you want. So in this example, we've got a few different areas. I'll be looking at the Canvas one in particular, and the base configuration for an interface group allows you to define the path where the data is going to be stored, as well as a time zone. And jumping right along to interfaces, this is where in ParkView right now, this would be your list of Park history sources. So you can have, say, a Kepler collector and a Matricon and other individual PLCs or DCSs in here, and each one you can have its own history path and time zone, as well as a file type. There's, by default, we're still storing data in day files, but we will have the option if you wanted to use monthly or yearly files, which Aaron will talk a little bit more about later, will probably be more commonly used for archiving purposes. So in here, I'll jump right along to tags, looking at that KEP source. So here's a tag list that this is pretty much one-to-one what you would see in the current Park History Excel tag editor. So this is all web-based now. So in this example here, we've got a few different tags from the Kepler OPC DA simulation server, along with the new data types that we've decided to map those specific tags to. And further over on the right, there's a digital tag mapping for the new digital tag type. where I've got one defined on this hour digital text tag for hour, and I'll show what that looks like. Brief mention though, we do have full support for exporting and importing from Excel as well. So if you have a large number of tags to work with and Excel is easier to do that in, you can export the tags lists from here and then re-import them back. So the digital tag mapping, in this example, I've created a digital tag map called hour. And what that allows us to do is, in this example, map a numeric value that's coming in from the OPC DA server to either a new numeric value or the same one, as well as a text value. So the example tag I'm using right now is the hour of the day tag that goes from 0 at midnight to 12 at noon, and then back to 1 through 11 for the rest of the day. And for this example, I'll show how we can then map 0 to 12 from the Kepler tag and end up with that showing in our trend. So here, the blue tag is the digital text tag that we defined. The green tag is the raw numeric tag coming from Kepler. And we can see at midnight, it was 0, but we've remapped that to 12, and then all the way through 1 through 12 at noon, and then back. So more commonly, this would be used for, say, a mode tag, where you wanted to show different modes. And then potentially, if you had different PLCs with different modes that you wanted to get all on the same numeric and text labels, you can remap values across them. So one of the other big things in the new historian is the ability to map multiple interfaces to a single park view source. So I previously mentioned that we had that Camus interface group with probably a dozen or more interfaces in it. And this example is showing that we have the one Kepler source that we were just looking at, plus every other tag in all the other interfaces in that group mapped to a single park view source. So that should make life a lot easier for people to find what they want, as well as getting sources into ParkView. Because if you add a mapping to say, I want all these interface group interfaces into a single ParkView source, every time you add a new interface, it'll automatically show up in the ParkView tag list without having to define a new source. And then you can do subsets as well. So you could say you want specific interfaces from an interface group mapped to whatever ParkView source. So moving right along onto, I had mentioned we were looking at supporting other deployment scenarios. This is something we just played with the other week, where we deployed the new historian into a Linux container and then deployed that into Azure. So since .NET Core is cross-platform, we were able to do that relatively quickly. And then we also used a Linux SQL Server as the configuration backend. So that could be an option for people if they wanted to look at maybe reducing costs compared to what a Windows hosting environment would look like. And then one more thing, as far I mentioned, we had the SQL Server Linux. This is also another option you could use, where Microsoft now has Azure SQL, which is SQL Server as a service. So we could support that as well for the configuration database, where Microsoft manages everything on the SQL Server side, and you just have the database that you're paying for that can have the performance scale to whatever you need. And on the web-based monitoring side, this is an example of what we've been looking at doing for the historian, specifically for monitoring all of the activity going on in the system. So this is a screenshot showing different performance characteristics of the historian, like CPU usage, memory usage, and how many tags are being written, as well as space usage. And this is all built on a open source graphing package called Grafana. So currently we're only exposing all of our historian metrics that would be corresponding to, say, the PEM tags that we currently have. Potentially, if there's interest, we could expose other tags, like all the tags and interfaces to this as well, if anyone's interested in pursuing custom dashboards using tools like this, like Grafana or others out there. All right, I'll hand it over to Aaron. He's going to talk about some of our future projects with the historian.
Okay, thank you, Steve. So Steve has kind of shown what we're doing so far, kind of where the state of things are that we're actually betaing at a few sites, and we have running and testing here. And I'll talk about some of our plans going forward. As Steve mentioned, part of the reason we wanted to work on this new historian platform is to set us up to start adding and expanding that and following a path of development that we think is going to be beneficial. So the historian going forward, I'm going to talk about 6 points. One will be the SDK or querying data, as Steve mentioned. The other one is expanding on how we can configure this in enterprise configurations. And I'll talk a little about historian to historian communication, which will be key for the enterprise configurations. Aggregation, data replication, how that's going to be expanded and adjusted for. And a mention about smart data aggregation, some of our ideas about how to help that for performance and load balancing, and then auto archiving as well. So an SDK or API, and this has been an ask by many of our customers, but making sure that we have a published, documented SDK or API for interfacing with this historian. So people can write within their own applications, things such as querying data, getting real-time and historical. It's going to be a .NET-based SDK, so it can be used in any language that you can work with .NET or load around that. We're also going to include the ability via the SDK to create and modify interfaces, create tags, and write or update values as well. So your applications that you could develop could actually create an interface, create some tags, and again, writing data to it. And we'll make sure that it's secure as well to prevent accidental connections that might modify your historical data, and make sure that's preserved and kept secure. So what we want to work on to help expand enterprise configuration is part of the idea of where there could be a corporate historian sitting on top of many site historians, and that we're sending up compressed, filtered, or based on some sort of configuration, data from the site historians. And that could either be scheduled as jobs or it could be streaming up there. So corporate users could be able to view the data at a network-wise, maybe near historian or cloud historian, while the sites may have the stuff on-prem with the data heading up. And then data requests from the clients could be either coming from clients at the site or clients at corporate. And the historians themselves can actually query the other historians down the chain for data. So for example, a client at corporate may be looking at compressed or aggregated data to kind of see their overviews, but maybe a subject matter expert there might need a higher density of data that's only stored at the site historian. And for them, it'd be fairly seamless. The corporate historian would actually pass that query down to the site historian and be able to send them the actual raw data that they may need for their analysis. And this is going to be key for what we're terming just historian-to-historian communication. So data may be streaming up from field historians to a site historian to a corporate historian. And for example, the field historian may be millisecond data. The site historian might be 1 second, 5 second data, while the corporate historian might have compressed, reduced, or hourly data. But data requests can also go from one to the other. So nobody along the chain of historians are really lacking that data density. It's trying to put the most useful data near the people that need it for those applications. And along with data, we're also going to be sending configuration information. So if somebody configures a tag or a point at the field historian that's linked to the site in corporate, that configuration will go up. So tag changes, descriptions, data types, formatting, all will pass up to the users that need it. Now, the next one is aggregation and data replication. So the site historian, or the kind of the bottom level of the historian, will be getting the raw data from DCS, PLCs, files, or whatever it's connected to. And then the site historian is going to be historizing that raw data and then in real time calculating the aggregate data and making that available to users that connecting up there. And then at the same time, that data, the complete set of data, could be streaming or replicated up to corporate, or could just be aggregate data sent up there, or it could be set up more in batches. So instead of a steady stream of data, it's setting it daily or hourly to do that data replication to the historian or possibly multiple historians. And then we want to work with what we're terming smart data aggregation. Many of our clients are choosing to aggregate all their tags in the system. So they always have plot reduced hourly, daily data instantly available. But sometimes as the amount of data they're collecting grows, they may want it to be a little more smart about deciding which tags are being used or which tags based on some configuration it makes sense to aggregate. So we're going to be recording and keeping statistics on the data requests and tag usage and auto aggregate the ones that are used often, or maybe the ones that based on a certain tag type or setting, the users have decided they would like aggregated. And this might benefit some of the cases where we are aggregating third-party historians by reducing the load and improving performance by not aggregating the total data sets, just only aggregating the data that the clients normally need. As well as utilizing auto archiving. Currently on a historian, anybody can manually archive older data across multiple drives, but we want to make sure that that can be configured to be auto archiving. And that may be distributing older data to a different drive, maybe from an SSD to a spindle drive, maybe to a different network drive, and then also set it up so it can maybe combine the daily sets of data into monthly or yearly sets for kind of a better organization of data. Possibly compress older data, remove it, change it from 1 second data to 1 minute data, or possibly even basically zipping that data up. That might make a data read a little bit slower, but have a less of a footprint on the hard drive, but still keeping years and years of data available. And some people have also asked for just auto purging of data. They know after 7, 10, maybe 15 years, there's no benefit for keeping that data around. So set it up that it would auto purge data. Well, that's kind of all the plans that we have going forward for the historian. There's going to be more that would be added. But right now, Steve and I are available to answering the questions you guys may have asked during this presentation or any that you guys can think of right now. Otherwise, thank you very much for joining, and we'll dive into these questions.
Hey,
No.
everybody. So let's get into the questions. We only have about, I think, 5 minutes to cover some of them. So unlike the last presentation, I'll make Steve answer everything instead of Alex making me answer everything. So
Right.
One of the questions is, will the historian be licensed by tag count, or is it a site license, or do we need a salesperson in the room to really answer that?
Probably, yeah, talk to the sales guys. I don't think we're planning on changing the licensing relative to how it's happening right now. So it'll just be a version upgrade and everything would still apply.
So another one was, have we looked into standardizing unit tables as part of the historian, or still free-form text for units?
Good question. Currently, it's exactly the same as how the current historian works as far as units, so it's free text. Adding unit conversion tables could go on our feature list if that's something people are looking for.
Yeah, and another option would be tying into the unit tables that we already have in the asset manager.
Right.
Is using the ISO 95 standard for those, so maybe could get a little relationship between those two, and utilize those. A question about the digitals: is it now able to map text to doubles and singles? So could our input tag be text, and then we match it to a set of text and numerics?
Yes, right now we could map if the tag is configured as a single floating point value, we can map that to a integer digital value. So there wouldn't be decimal places on the conversion. It would be taking the closest decimal value and mapping that to the text value. And then same for going text to numeric. It's currently integer, only numeric values.
Okay. It seems like people were excited about SDK, but they're asking, and I guess this is outside of the historian work, will that SDK extend to third-party sources that we have, or even to things like Alarm's asset framework and et cetera?
Yeah. Eventually, the first version of the SDK we're talking about for the historian would be specific to the historian data going in and out of the tags that we're storing. The SDK for third-party historians would be more geared towards accessing the UA server that is what exposes to third parties. So that is in the works as well. I know multiple people have asked for it, so we'll get there down the road.
We're currently doing development on an asset manager SDK, correct?
Correct. Yeah, that's also in the works.
Let me see. What else do we have in there? So I think there's a lot about the storage of aggregates. One was we have automated recalculations of aggregates, probably based on input data changing or something like that.
Yeah, so the historian, since it's both storing the raw data as well as calculating the aggregates, would automatically know to invalidate any periods that have been changed because of the raw value coming in. If you updated or inserted a value back in the past, it would automatically recalculate whatever periods might have been affected by that for the aggregates. And then eventually we're also planning on storing the third-party aggregates in the new historian as well, and that would be a different subject for how to detect if something changed in one of those historians. Right now it's a manual process for our existing aggregate server.
Okay, yeah, so with the new one, it will know a value's changed because it's gone through, and if somebody asks for an aggregate, it might do it on the fly, and then a job would recalculate that aggregate and get the aggregates back in sync.
Right, yeah, so the historian would immediately know that calculated aggregate's no longer valid and would go and recalculate it on the fly and not return the wrong value. And then there could be a background process to update those if there's a whole lot that need to be recalculated.
Okay, I think that's all the questions. I don't know if you've seen any more. Steve coming in, there's another one in the regular chat, just encouraging units, a standard set of units would be good. And I think we can leverage the asset framework and its system in that. But like we said in the presentation, we're trying to set a base for, you know, a good historian that then we can extend into things like SDK and communication and more security and et cetera. Okay, well, we're going to wrap up here in about 1 minute at 10 o'clock Pacific time. You're gonna have Jacob jump on again, and he's going to introduce our next presentation. So thanks for joining Steve and I, and talk to you all soon.